Most automotive battery cases are constructed of polypropylene plastic, which is a thin, very strong and lightweight plastic. You'll notice that battery cases do not split up very easily. They get in accidents, they get dropped, they hold themselves together. Industrial and truck batteries are constructed of hard, thick rubber material. And if you ever look at any of these larger trucks, you'll see the batteries are black plastic and even heavier. Right? Inside the cases, there's 6 cells. Right? 6 cells are what give us 2.1 volts each to give us a 12.6 volt battery when it's fully charged. And it has positive and negative plates inside. In the bottom of this case, there's ribs to support the lead alloy plates and provide a space for the sediment to settle. Right? There's all kinds of debris that comes off these plates, minerals that might be put in there with the wrong water that's put in. But whatever happens, if anything touches both plates, it will short the battery out. So we have to have a little kind of an area for that debris to settle into the bottom of a battery, and you'll see that inside. That's the sediment chamber, and that prevents any spent material from causing a short circuit between the plates in the bottom of the battery. Right? So we have a battery in the classroom, and that's usually what I pass around because you don't get an opportunity to see what's inside. But I'm going to try to help you visualize it. So if you look in here, you'll see there's the plates. They sit, and underneath here, there's a little gap down below. So it holds these, and it gives a little bath underneath it for them to just settle. And these are the separators that go in between the plates, right? None of the plates are touching each other. Right? The plates have a grid. They have a radial design, right? They stem out from the outside. You'll see all different shapes and sizes, and it's all ways that are supposed to give you the surface area. They are supposed to give the pathway for electrons to be able to flow and that kind of stuff, right? So a grid with a radial design has lower resistance and can provide more current more rapidly than a non-radial grid. And you'll see a picture of that a little bit later on. The battery we have in the classroom is a non-radial. It just looks like a rectangle with small rectangles all over the place. Right? The radial spokes act as a superhighway for the current to travel from all areas of the grid to the battery post. Right? So the battery post lives at the top, and all this stuff kind of promotes it coming upwards, right? So that's going to make one battery different from another battery. Right? The cells are positive and negative plates. Each have insulating separators between each plate. A cell is called an element, and it's actually a 2-volt battery. It's 2.1 volts. That's why you heard me yelling over that video, because a 12-volt battery is almost dead. A 12.6 volt battery is fully charged, right? So it's roughly a 2-volt battery, regardless of how many plates or negative plates are used. So if we have 6 of them, if we have 8 of them, if we have 10 of them, right, it's always coming back to a little over 2 volts. The greater the number of plates in each cell, the greater amount of current can be produced. This is why you'll feel one battery and it feels ungodly heavy compared to another battery. Typical batteries contain 4 positive plates and 5 negative plates per cell. A 12-volt battery contains 6 cells connected in series, producing 12 volts, and has 54 plates. Now, other batteries might be different than that, right? That's your generalized type of a battery. If the same battery had 5 positive plates and 6 negative cells, that would be 66 plates, and it would have the same voltage, but the current of the battery would be increased, right? So when you buy a top-level battery, a higher cranking amp battery, it has more plates inside. And that can be the design of those plates, right? If the plates have more area on them, they'll promote more current flow as well. Right? So if you look inside, I grabbed some pictures for you just because I don't have a battery to hand to you. So if you look over here, right, you'll see how the plates are connected in here, right? And they're all tied together within. you can see that the one battery post is connected to all of the negative plates, or just the positive plates. And then the negative side is connected to all them. So they're all looped together and they're sandwiched in between each other. Here's what a non-radial plate looks like, and they can coat them with the material. You heard one's lead and one lead oxide, right? That lead oxide is a coating that can be on it. So, like, here's your case. Here's the empty case. This is where the cells would sit, and those grouping of plates. And you'll see here's a complete plate assembly. You have these contacts that touch them as you go across, and you see this one. Here's the negative plates, and here's the positive plates as they slide together. And here's the individual, right? It's called paste that's covered on them. And you can compare. Here's the separator. There's the negative plate, right? Lead and lead oxide. And gives you a little bit more of an idea of what's actually inside it. Right, so the acid, so to speak, that's inside is an electrolyte. And the electrolyte used in automotive batteries is a solution of 36% sulfuric acid, 64% water. This is used on lead antimony and lead calcium batteries. The lead calciums are maintenance free. They're the ones that you can't add water. Lead antimony batteries were ones that had caps on the top. Right? The chemical symbol for sulfuric acid is H2SO4. H is for hydrogen. There's 2 atoms of that. S is for sulfur. O is for oxygen, and there's 4 of them. That's why it's H2SO4. The electrolyte is sold as pre-mixed, and the proper proportion is a factory installed thing. Sometimes you'll buy a battery like for a motorcycle, and it'll come with a little container of the acid that you'll install later, but it's pre-mixed. Additional electrolyte must never be added to a battery after the original full. You just change the proportion of what's in there. The other thing that comes in is distilled water only gets added, because if the water has minerals in it, that mineral will bond to those plates and reduce the capacity of the battery.